Device monitoring involves continuously checking the status, performance, and health of network devices to detect potential issues proactively. Monitoring is crucial for network administrators to ensure optimal network performance and minimize downtime. Two essential protocols used for monitoring are SNMP, Simple Network Management Protocol, and ICMP, Internet Control Message Protocol. SNMP, Simple Network Management Protocol, is a widely adopted protocol used for monitoring and managing network devices. It operates on an agent-manager model, where the agent runs on the devices to be monitored, and the manager collects and analyzes data from these agents. SNMP relies on a Management Information Base, MIB, which organizes and defines the data variables for each device, enabling consistent and standardized management across different network elements. In the practical example of configuring SNMP on a Cisco router, the administrator initiates the process by entering the configuration mode after enabling privileged mode with the enable command. Within the configuration mode, the administrator sets up SNMP using the SNAP server commands. The command SNAP server community public RO activates SNMP with the community string public in read-only RO mode, allowing the SNMP manager to retrieve information from the router but not make changes. Additionally, the administrator sets the location of the router with SNAP server location main office and provides contact information with SNAP server contact network admin, which serves as valuable metadata for the SNMP manager's reference. By configuring SNMP in this manner, the Cisco router becomes accessible to SNMP managers, enabling them to collect vital data, monitor the router's health and performance, and take necessary actions to ensure the network's smooth operation and efficient management. Device management is a critical aspect of network administration, and remote access methods play a significant role in efficiently managing devices. Three common methods for remote access are Telnet, SSH, and HTTP/HTTPS. However, Telnet poses security risks as it transmits data in plain text, making it vulnerable to interception and unauthorized access. Instead, network administrators are advised to use SSH, Secure Shell, for remote access, as it encrypts data, ensuring a secure connection. HTTP/HTTPS can be utilized for devices with web-based management interfaces, providing an intuitive and user-friendly management experience. To illustrate the practical implementation of secure remote access using SSH on a Cisco switch, administrators follow a series of configuration commands. First, they enable privileged mode with the enable command, followed by entering the configuration mode with conft. The next step involves creating a local user admin with the highest privilege level, 15, and setting a secret password for secure authentication. They then set the domain name for the device using IP domain name mycompany.com, right single quote, to support SSH key generation. The administrator generates RSA keys of 2048 bits to facilitate secure communication. Finally, they configure the virtual terminal lines, line VTTY015, to accept SSH connections only, transport input SSH, and specify local authentication, login local, for secure access. By implementing these configurations, the Cisco switch is now accessible through SSH with encrypted communication, ensuring a robust and secure remote device management solution. Configuration management is a crucial aspect of network administration, and regularly backing up device configurations is essential to ensure network stability and facilitate quick recovery in the event of failures or configuration errors. Two common methods for configuration management are TFTP, Trivial File Transfer Protocol, and SCP, Secure Copy Protocol. These methods allow network administrators to efficiently store and retrieve configuration files from remote servers, maintaining a reliable record of device settings. In the example of backing up a Cisco router configuration to a TFTP server, the administrator begins by entering privileged mode with the enable command. Then, they use the copy running config TFTP command to initiate the backup process. The system prompts them to enter the IP address, or hostname, of the TFTP server, in this case 192.168.1.100. After providing the remote host's address, the system requests a destination file name for the backup. The administrator specifies myRouterConfig backup as the file name for the configuration backup. By executing these commands, the running configuration of the Cisco router is safely copied to the TFTP server, with the designated file name. This ensures that the network administrator has a reliable backup of the device configuration, allowing for seamless recovery in case of any unforeseen issues or changes that may impact the network's stability and performance. Device maintenance is crucial for ensuring optimal performance, and one vital aspect is regularly updating device firmware. Firmware upgrades are essential to address bugs, add new features, and enhance security in network devices. For Cisco devices, firmware upgrades can be seamlessly performed using the Cisco IOS XE software upgrade feature. In the practical example of upgrading the firmware of a Cisco router, the network administrator enters privileged mode with the enable command. Next, they use the copy TFTP flash command to initiate the firmware upgrade process. The system prompts them to enter the IP address, or hostname, of the TFTP server, which in this case is 192.168.1200. They provide the file name Cisco_IOSA, March 1st, 17, bin as the source, which represents the new IOS XE image to be used for the upgrade. The system also requests a destination file name for the new image, but the administrator can simply press Enter to use the default file name. By executing these commands, the administrator successfully upgrades the Cisco router's firmware by copying the new IOS XE image from the specified TFTP server to the device's flash memory, ensuring the device remains up to date and benefits from the latest improvements and security enhancements. Effective password management is paramount in network security to thwart unauthorized access to devices. Cisco devices provide robust support for AAA, authentication, authorization, and accounting, to implement user authentication and authorization policies. In the practical example of configuring AAA on a Cisco switch, the network administrator enters privileged mode with the enable command and then enters the configuration mode with conf_tt. They enable AAA globally with the command AA new model. Subsequently, they set the authentication method to local using the ALA authentication login default local command, which signifies that users attempting to log into the switch will be authenticated against the local user database. Additionally, the AAA authorization exec default local command specifies that the authorization for privilege level access is also handled locally. By executing these commands, the administrator reinforces password management by configuring the switch to verify user credentials against its own local database, ensuring secure access and protecting the network from unauthorized users attempting to gain entry. We hope this video helped you on your journey towards becoming a cybersecurity expert. Remember to subscribe to our channel and turn on notifications so you never miss out on our latest content. And if you found our videos helpful, please give us a thumbs up and share them with your friends and colleagues. Don't forget to check out the links and description for our Anki flashcards and to donate to St. Jude Children's Research Hospital. Your support can make a real difference in the lives of those in need. Thanks again for watching, and we'll see you in the next video.